Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 1, Lesson 1. Let's get started. Okay, so here is your work today, 2 plus 2 plus 2 plus 2. Seems pretty simple. It's not actually our work, but I wanted to make a point that you learned a while ago that instead of writing this repeated addition, we could write it in a different form, different type of notation. So you learned that repeatedly adding 2 4 times is the same as 2 times 4. And repeated addition, we decided, was actually multiplication. So this is really just a notation for repeated addition. Repeated addition is multiplication. And then, we learn a lot of multiplication facts, and we have algorithms that can help us to multiply bigger numbers together, and it's helpful. Instead of, imagine having to write 85 twos added together. So you'd have to just keep writing 2 plus 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 2. And the bad part is, other than it takes a long time, you get lost and you forget where you're at. And right now I don't have any idea how many 2s I have. I'd have to count them: 2, 3, 4, 5, 6, 7, 8. And 8, okay, so I need 77 more. It's not worth it, right? So why not just write in multiplication form, write it in this notation, and makes things a lot easier. So then the question is, well, what about if we were doing 2 times 2 times 2 times 2? And we have the same problem, right? If I wanted 2 times 2 85 times, then I've got the same issue. It's going to take me a long time to write it out. I'm going to get lost. I might not get the right number of 2s. I might be one off. So many problems. So what we need is a notation where we can write repeated multiplication, right? So down here we have repeated multiplication. So what could we do to solve this problem? Well, you learned in 6th grade that repeated multiplication is an exponent, where we write the number that is repeatedly multiplied as the base, and then the number of bases as the exponent. And that means repeatedly multiply 2, and there are 4 of them. So we do have that, right? But now we know that repeated multiplication is exponential notation, or exponents. So we do have that, and that's what we're going to be working with today. So hopefully you listen to your 6th grade teacher, whoever that may have been, when they said, you're going to need this in 8th grade because today is the day. So let's take a look at some of our work today, and let's just understand that we know that, let's take that 5 to the 6th power. We know that the 5 is called the 5 is called a base, and the 6 is called an exponent, and together, all of this together is called a power. So if I gave you that, so we have a power which is made up of a base, in this case 5. The base is the number that's repeatedly multiplied, and then an exponent, and the exponent just tells us how many bases there are. So it's really just an instruction. It's a notation. It's a note saying, write this as 5 times 5 times 5 times 5 times 5 times 5. 5 repeatedly multiplied together, and there are 6 of them. So instead of writing it out that way, this exponent means the same thing, right? The 6 tells us that there are 5 bases, or 6 bases multiplied together. Okay? Now, that you should have seen before. That should be familiar, and you should be able to recognize this. This other one is a little different, but let me explain that using the 5 to the 6th power idea. What it's saying is this. 5 to the 6th power is the same as repeatedly multiplying 5. So 5 times 5 times 5 times 5. Just repeatedly multiply 5. And then do that 6 times. So you're going to have 6 5s repeatedly multiplied together. And it's the same notation. So using the variables up here, it's easy to see that on the top is the base, right? These x's are the base. So we're saying repeatedly multiply x. We don't know how many there are, but that's what you're going to do. You're going to repeatedly multiply the base. And then this exponent n tells you how many times to do that. Well, we don't know what n is, so we just say n number of times, whatever it happens to be. So those two notations are interchangeable, but obviously the exponential notation is much simpler. But this tells us what's actually going on. Like if we have variables, it's a little easier to understand what's happening. Okay, so let's try some of these. I've been given exercise 1, and I can see that the 4 is repeatedly multiplied, so that's the base. And this 7 tells me how many times. That's my exponent, so it's 4 to the 7th power. Those are equivalent. Exercise 2, I've got, 3.6 is the base, and they've written that here. And they wrote the exponent in already, so that's the number that goes here. It's 47 times. 47 times. So repeatedly multiply 3.6, and there are 47 of those to multiply together. All right, here's another one, exercise 3. Let's see, the base is negative 11.63. So I need to put this base in parentheses because of that negative sign, and we'll talk more about that in a little bit. And then 34 is my exponent, so the 34 goes there. Exercise 4, let's see, I've got 12 is the base, 15 is the exponent, so the 15 goes here. Again, in exercise 5, I have a negative. So let's see, I've got a negative 5 is my base. That's the number that's repeatedly multiplied, and 10 is my exponent. So it should look like that. Before we go any farther, let me just make a mistake down here. I'll put that in red so we can see that it's going to be wrong. If I wrote this as negative 5 to the 10th power, what happens is this, what's raised to the 10th power then is just the 5. So that would be 5 times 5 times 5 times 5 times 5, etc., 10 times. And then the result would end up being negative. Whatever the result of 5 to the 10th power happens to be, then we would apply this negative at the end. Completely different than the right answer, which is this one, because what we're doing here is we're raising whatever's in the parentheses to the 10th power. And that's what we're asked to do. I mean, that's what it says on our other notation here. So very important that you use those parentheses when there's negatives involved. Okay. 6. This is, my base is 7 over 2, and I'm going to repeatedly multiply that 21 times. So what I'm going to do is I'm going to say this entire fraction is repeatedly multiplied together 21 times. Number 7, again, I've got a negative, so I'm going to say negative 13, and the exponent is a 6. negative 13 to the 6th power. Okay, so as we go through these, you can pause the video and try some of them yourself, and then watch the solution to just make sure that, you're getting some practice. Here I've got a base of a negative 1/14, and my exponent is a 10, so that's negative 1/14 to the 10th power. Here my base is an x, and my exponent is a 185, so it's x to the 185th power. All right, and then down here, well, I've got x is my base, so that's from here, so there's the x. And then the exponent is an n, so how many times am I going to multiply? How many x's will I multiply together? Well, n number of x's, whatever that happens to be. All right, let's move on. Exercise 11, will these products be positive or negative? Well, let's talk about this. Let's do we're going to do negative 1 multiplied together 12 different times, 12 different negative 1s all multiplied together, and let's see what happens. Negative 1 times negative 1 equals a positive 1. Okay? If I do a negative 1 times a negative 1 times a negative 1, that gives me, let's see, negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1, so that's a negative. And let's keep going. Negative 1 times negative 1 times negative 1 times negative 1. Let's see, negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is a negative 1. Negative 1 times negative 1 is a positive 1, so that's a positive 1 again. Let's do one more. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1. That's 5 of them. Negative times negative is positive. Times another negative is negative. Negative times negative is positive. Positive times negative is negative. So this one's a negative 1. And hopefully you can see what's going on here. If I use 2 negative 1s, I get a positive. If I use 3 negative 1s, right? 1, 2, 3. If I use 3 negative 1s, I get a negative. If I use 4 negative 1s, if I use 4 of them, that's a 1, 2, 3, 4 of them, I get a positive. If I use 5, 1, 2, 3, 4, 5, if I use 5 negative 1s, I get a negative again. So you see the pattern. Even numbers, if your exponent is an even number, you're going to get positive results. If your exponent is an odd number, 3 and 5, you get negative results. So that's a nice quick way to know. Even if we use really big numbers, it's not going to matter to us because we know if my exponent is a positive, my answer is going to be, if my exponent is an even number, it's going to be positive. So let's take a look at these. I've got negative 1 raised to the 12th power. Well, that 12 is even, so I know my answer is going to be positive 1. It's positive. And then down here, I can see that my exponent is odd, and since that's odd, it means I'm going to be left with a negative answer. So this one's going to be a negative 1. So a little shortcut there. That should help us and save us some time. So let's try that out with exercise 12. Well, I've got negative 5 raised to the 95th power. Well, it's going to be a big number, right? I'm not going to do this mathematically right here, but I do know, without doing any calculation, that since this is an odd exponent, I know that my answer is going to be negative. It's going to be negative. The number is going to be really big, right? 5 times 5 is 25, times 5 is 125, times another 5. We're getting big numbers, and we've only used 3 or 4 5s. We need 95 of those put together, so it's going to be a really big number. But I do know, I would use a calculator, but I do know that it's going to be negative. Okay, and then one more. I look at my exponent. It's an even number, so I know this is going to be a positive. It's going to be a positive number. Negative 1.8 times negative 1.8. 122 of those multiplied together is going to be a massive number, but I do know that it's going to be a positive because the exponent is even. And that makes things a little easier. Okay, let's go to our last group of exercises. 13, fill in the blanks with a positive or negative. Okay, if n is a positive even number, if that's an even number, if that exponent is even, I know that it's going to be a positive result. And then if n, which is our exponent, is an odd number, well, I know that it's going to be a negative result. All right, 14. Let's see. Josie says that negative 15 repeatedly multiplied 6 times is a negative 15 to the 6th. So I've got two problems here, and let me see if I can explain those to you. Here's the first. The exponent is even. So I know that my answer, all right, the exponent's right here, I know that my answer will be a positive answer. So first of all, I know that Josie's incorrect because she has a negative in her answer, and that won't be the case, right? I know my answer is going to be positive because of that exponent, which is an even number. So there's number one. The second problem I have is the way Josie wrote this. So look, she wrote negative 15 to the 6th power. Well, that means 15 to the 6th power, whatever that is, and then we'll apply this negative at the end. So this can't be correct, right? She used the wrong notation. Well, what it should be is the negative 15 is repeatedly multiplied, so that is the base. Negative 15, and there are 6 of them. There's our exponent. That's a 6. And so first of all, this is what her notation should look like. And second of all, I know that's wrong because she has it as a negative, and there's no way it can be a negative since our exponent is even. All right? Okay, that is lesson 1. Hope that helps. See you again next time.